You ever see a new feature just pop up on an app on your phone and wonder, hey, how'd that get there? Well, it's not magic, but it's a pretty amazing process. Today, we're going to pull back the curtain on how companies take a simple idea and turn it into code you can actually use.
So how does that happen? It's a whole journey, really. It goes from just the spark of an idea through this gauntlet of automated checks and human approvals. It's all designed to get you cool new stuff without breaking what's already working. Modern software engineering has turned this whole thing into a high-tech assembly line. All right, let's dive in.
You know, every great feature starts not with a single line of code, but with a simple sentence. It's called a user story, and it's written from your point of view. Something like, as a user, I want to save my favorite items to a wish list so I can find them later. That's it. That little sentence is the blueprint for everything that comes next.
Okay, so this is our roadmap for this whole explainer. This is the path that user story is going to take. We're going to follow it step by step from the very first automated tests all the way to watching how it behaves out there in the real world.
So a developer takes that wish list idea and writes the code, but they can't just drop it into the main app. No way. First, it has to enter this major phase, an automated series of checks and balances we call continuous integration, or just CI. This is where the machines get their first look.
And the key word here is continuous. This isn't something that happens once a week. It happens all the time, with every little change a developer makes. And the goal? It's to find bugs and problems immediately, not weeks down the line when they've become a huge mess. It's all about integrating early and often.
And that right there is the million-dollar question, isn't it? How do you add new stuff without wrecking the old stuff? And CI is the answer. The best way to think of it is like a security system for the code. Every time a new piece of code is added, a whole bunch of alarms, in this case automated tests, go off to make sure the new code plays nice with all the old code.
And what's really cool is just how thorough this is. You have unit tests that check tiny little individual pieces, like a single button. Then integration tests make sure all those little pieces work together. And then you have regression testing. That's the big safety net. That's what makes sure our new wish list feature didn't, accidentally break the shopping cart. So important.
So, how do teams know if their tests are actually any good? Well, one key metric is something called code coverage. It basically tells you what percentage of the new code is being checked by these automated tests. And while 100% is kind of the dream, getting a high number like 90% gives the team real confidence that the code has been put through its paces. Okay, so our feature survived the robot gauntlet. What's next? Well, now it's time for some human oversight. This is where we enter the continuous delivery phase, or CD, and this is where people get involved to ask the really big picture questions. Looking back at our map, we're now at these two steps, QA and UAT. At this point, the code is put on a staging server. Think of it like a perfect copy of the live app that only internal people can see. And for the first time, real people are going to use it and, maybe more importantly, try to break it. And this is the fundamental question for the quality assurance team. They're not just hunting for bugs. They're looking back at that original user story and asking, does this feature actually solve the problem? Does the wish list work? Is it easy to use? Does it feel right? It's about the whole experience. Now, this brings up a really critical difference in how companies operate. With continuous delivery, the code is totally ready to go live, but a person has to make that final call and push the button. Continuous deployment takes it to the next level. If the code passes every single test, it just goes live. Automatically. No button needed. It's the ultimate trust in your automation. So, our wishlist feature has survived the machines, and it's been signed off by the humans. It's gotten a big green light. Now it's time for the main event, deploying it to production, where millions of real users are waiting for it. This is it, the moment of truth. The new code is rolled out to the live servers. But even this is done really carefully. A lot of times, companies use a technique like a Canary Release, where they'll give it to maybe just 1% of users first. They watch it like a hawk, and only if everything looks good do they roll it out to everyone else. But the work is not done just because the feature is live. Not even close. In fact, a whole new phase begins, constant monitoring. Teams use these powerful dashboards to watch for anything, error spikes, slow performance, anything unusual. The system is always being watched to make sure it's healthy. This entire CI/CD pipeline is always getting there, always evolving. And one of the most powerful modern approaches that builds on all this is something called GitOps. It really changes the game by using a tool most developers already know, but in a totally new way. So what does that actually mean, GitOps?
Well, it means the absolute source of truth for what the entire live system should look like. Not just the app code, but the server setups, the networking, everything. It all lives inside a Git repository.
This slide shows the idea perfectly. The Git repository is the master blueprint. Then you have an automated process that is constantly comparing the live environment to that blueprint. If it sees any difference at all, it automatically corrects the live environment to match. You're basically turning your whole infrastructure into code, which makes the whole system way more transparent and easier to manage.
So, this whole system, from CI/CD all the way to GitOps, it's all about using automation to build and release software faster and more reliably than ever before. But as these automated safety nets get smarter and more comprehensive, it really makes you wonder, what's the future of that manual human checkpoint? Is it an essential safeguard, or is it just a final bottleneck we'll eventually engineer away? Something to think about.